Hello everyone, my name is Rebel E, but in the academic field, I prefer people to call me Nicholas. Yeah, that's my preferred name in mathematics or in any academic courses. So in this, start from this summer, I want to start a course which is called the um, probability and process. So it's mainly about math stuff and a little bit about like to model the realistic situations. The probability is, as everyone knows, if you toss a coin and you get 50% of the probability to get ahead, and that's probability. And the process is so much more abstract concept. For example, very commonly known as the stochastic process is one process, stationary process, or even like birth and death process. That's a process. It's like a yeah, it's a process. It's start moving from one node to another node and to another on the chain. So that's a process. So in this course, what we will learn about is probably, as you can see, probability models and random variables, conditional probabilities, probabilistic distribution, and those are very basic terms, and central limit theorem. And before that, we'll talk about like Markov inequality and Chebyshев inequality as two prerequisite. Also like multivariate transformation. That's for like multi-dimensional random variables and moment generating functions. Statistical analysis. This term is not very regular people meet in probability course, but it's like if you have a sample, already have a sample, and you have and you want to know about what the population be like, and that's be like called reversely analyzed population. That's called statistically analysis. But if you don't understand what's population, what's sample, that's fine. So this is not like I assume you already know before we talk about that. Markov chains, Monte Carlo techniques, deep sampling, harmonic functions. Those are Markov chains problem, which are really nice. And later on we have a stochastic process and other tools and options for analyzing realistic problem. So if you are like me, I'm currently a UW student. I'm like moving to senior from next autumn. So if you're math UW student or stat student, this is the same coursework as 394 to 396 and 491 to 493. The six courses combined. So I will talk about them from now, maybe 1 year or 2 year later. That's possible. And what I will use for this course, what material I will use. First of all is lecture slides by the professor Alexander Giesing. He's a very wonderful professor in statistics, and I took his course for 2 quarters. One is 394 and 390. Both are statistic courses. So his lecture slides is I think it's much better, much better than what the lecture what his lecture is and what the textbook is usually rated. So there are many examples. Some are really advanced, some are easy to understand, which serves very important tools for our understanding. Also, Introduction to Probability, and this is a book. I actually have a version here. It's look like this. And I will use this book to guide through the second part, and mostly about like multivariate random variables and its relative calculation, something like that. And also I will use another book. It's a finite Markov chain and Monte Carlo methods, which is written by Tim Mesicap and Somik Paul. I don't know who those guys are, but this book is really easy to understand when you have nothing in mind about like graph or about like random walks. So yeah, it might be helpful. And I took this course with a professor named Andrea Orsolini. He's from Stanford. He's graduated from Stanford 2 years ago with a PhD of mathematics. His also very nice and very knowledgeable, I would say. A very clever guy, you can see from his eyes. So I will use this book from my experience because it's really helpful when I'm taking his class. Okay, and so this is not a math class for elementary student or maybe some, but not the majority elementary student or children. So I already assume that you know something before we can start. So first of all, I assume like you know some like high school mathematics. That's all the thing about like what's addition, like subtraction, or some mathematical operations, and you can do like a root, square, something like that, and you know a little bit about like what a function is, like like y equals to 2x, something like that, and basic geometric shape like circle, triangle, and square, rectangular, something about that, and also maybe like what's frequency. So I will now talk about like the definition of frequency and relative frequency or like density. I already assume you know that. And mathematical induction set theorem, those are about like the most basic thing about like mathematical reasoning. Induction is a relatively useful method in improving. So also like if you take calculus class, you must know differentiation, integration. It's not very it's not say that you must know everything about integration, like different method when you meet like x squared plus 1 divided by 1, something like that. Those are like very advanced integration, but at least you know why we need to integrate and how it works. And for like most basic example as like x squared, how to take a differentiation and integration, and that's okay. And also assume like you already know the permutation and combination. That's just two formula, but you will have a like fundamental understanding of why we use those formula and how they serve in our in realistic problem. Also real function that's like real number function, sequence and series convergence theorem. For example, like 1 over n. This is a number. Now it's a number, but if we say like n can be any natural number, so in this case 1 over n, as n grows into like infinity, it is is this sequence or is this sequence converge or not? So so we will prove that it is not convergent, it is divergent. But that's like a fundamental knowledge of convergence theory. And anything related to that, like for example, like the absolute convergence theorem and the comparison convergence theorem and the Cauchy convergence theorem, something like that. So and also especially for like stochastic process and Markov chain is very important to know about what matrix, because that's not high school math, but matrix is really helpful when we are building like the Markov matrix and use a matrix to go through each process. And linear combination, that's from linear algebra, and what's eigenvectors, eigenvalues, and determine what those definitions are. And if you know, and if you confirm like okay, I know everything about that, I know most of things, I'm familiar with that, then we are really ready to like start with this course named probability and process as a whole. So yeah, that's about like introduction to this course, and I'm really sure that many people will enjoy this course because they may find it difficult while they are first confront with them in the big lecture hall and with tons and tons of the homework. So if you feel that you have some not understand really well, maybe the video following will be helpful to you. So today is Wednesday, and yeah, it's Wednesday. So I think I can upload videos like once a week, but absolutely this week will be another, like actually starting with the course. Today is just introduction. So Friday will be another lecture and upload it. And I try my best to upload once a week, but I'm not sure. I'm also like student in UW, University of Washington, and I have lots of things to do currently. So it's not guaranteed, but usually the frequency will be like, yes, the frequency will be like once a week to go through the course. Okay, and have a nice day.